Renewable energies will lead to a change that will have a huge impact on our future. What might look simple on the outside is only possible with a reliable and secure power grid. The energy transition makes grid planning and operation increasingly complex, and Velio supports grid operators to meet this challenge. The Intelligent Grid Platform is a software assistance system that digitizes technical grid planning and operation processes. It provides multiple applications in 3 main areas. In the area of data quality, a complete digital twin of the entire grid is developed. With this model, typical grid planning processes can be automated, such as connection impact analyses for new generators or consumers. In the area of grid operation, live measurement data is integrated in order to identify grid bottlenecks in real time. Processes that used to be very time-consuming can be completed in minutes. Renewable generators and charging points for electric vehicles can be integrated faster and with less costs. This does not only benefit the climate, but also our society, as the energy transition remains affordable. Velio, digital transformation of electricity grids.
Wait, what, sorry?
Vilnius.
Vilnius.
It's,
Vilnius.
Which one? Vilnius. It's Austria.
Welcome to Vilnius, Austria, the undiscovered jewel of the Alps. Vilnius is characterized by having most of its landmarks just a few minutes away from each other by foot. This admirable city is in the heart of Austria.
Vilnius? In Italy?
In the heart of Italy, being its most well-kept secret. Its effervescent streets and colorful markets make it a perfect destination for any traveler. For obvious reasons, Vilnius is the pride of Italy. The pride of Finland. Vilnius's old town, considered one of the biggest in the region, is crowned by the majestic Gedimino Tower, where travelers like this young fellow, hello there, buddy, can have the same view that the old ruler of Finland, the old ruler of Venezuela.
Sweden?
Sweden.
Belgium.
Oh, okay.
Ethiopia.
Of Ethiopia.
Romania.
What if I told you that Vilnius is the capital of Lithuania?
would never know.
Yeah? Yeah. There you go. Yeah, okay.
Yeah, that's right.
Yes!
Welcome to Vilnius, Lithuania.
The Netherlands is a small but resilient country. We have always been at the forefront of innovation. When faced with a challenge, we take it on to find answers and solutions that make the world a better place. From protecting ourselves against the seas to pioneering technologies such as Wi-Fi.
Over the last 10-15 years, we have produced remarkably successful companies within Europe, but even on a global level, it's quite exceptional. And if you then subsequently look at what's going on in Holland right now, I believe the future looks very bright for our country, so a lot to be proud of.
Technology may be the key to the future, but it's the people with great ideas that hold the key in their hands. The bright minds, the innovators, and the change makers. These people deserve our support to rise to today's challenges. We need to empower Dutch leaders and provide them with an ecosystem for innovation to ensure the Netherlands stays an innovation leader with a competitive and relevant economy in this rapidly changing world.
The Netherlands might look like a small country, but it's very important that we stay ahead of these developments and instead of be the follower.
The entrepreneurial spirit that we find in the can-do attitude, the level of ambition in Holland is something I haven't seen in many other countries in Europe. So I think it's time to act, and it's time to act now.
We are TechLeap, We empower Dutch leaders with support when it comes to access to capital, talent, markets, and technology. We bridge the gap between where they are and where they want to be.
I really believe that Tech Leap can make a difference, and that's the reason also why myself and some of my colleagues have decided to spend some of our time really bring our experience to help some companies and some startups scale up in Holland and having the global impact that we've had with our own companies.
Together with the ecosystem, we help people with great ideas to reach their maximum potential in the world of today and in the world of tomorrow. Tech Leap, empowering Dutch leaders in tech.
Ladies and gentlemen, welcome back to the Energy Summit 2020. So we hope you had a great break and we are excited to move on with our agenda today. So basically, what we are about to do is that we are going to present the very first category finalists from the new Energy Challengers. The top 5 companies in the battery category will now pitch live to the judges in this studio. For that, please welcome the jury. Jesse Teichman, who is the investment manager at Chevron Technology Ventures. Friedrich Bishop, who is the director manager at the Rockstart. And of course, our own Rakas Pečeliūtis, who is the founding and managing partner at Contrarian Ventures. Hello, gentlemen.
Hi.
How are you feeling? A bit more smile on your faces would do the trick. Yes, that's what I'm talking about. That's what I'm talking about. Well, welcome. Welcome to the studio, and I'm really excited about your really tricky Q&A sessions. But we're going to move forward with that a bit later. So a couple of technicalities before we start. So each company will have 5 minutes sharp for the pitches and 5 more minutes for Q&A sessions. And the companies are usually pitching in the alphabetical order. So let's move further with the finalists. So please welcome the very first company pitching straight from the USA, whose CEO Jenna King will represent. Jenna, the floor is yours. And your time starts now.
Part of it is there's just more product in the market. If you think of how many batteries you even have on your person, in your car, in your home, we are going to see more and more incidents. The 3 main causes of lithium battery failure: overcharging, so you have a failure of your battery management system; internal short, where your battery management system doesn't even have the opportunity to help because it has to do with a short within the individual battery cell, either caused by a material defect, manufacturing defect, or some sort of trauma to the battery. And of course, external heat. And the point to make here too is the higher the energy density of the battery, the more catastrophic the failure. And it's a big issue for some of the new chemistries that we're looking at, such as nanosilicone and lithium metal. So our solution, what we've done at Safecore, is we actually add a fuse into the individual battery cell. And it's a chemical fuse. We coat a material on the current collector of the battery between the current collector and the electrode material. And so in the event of a thermal runaway, what happens is this layer, the Safecore layer, actually delaminates and creates a non-conductive gap within the individual battery cell. And so what you're doing there is you're slowing the release of energy within the battery. So rather than all that energy coming out along the very conductive current collector and causing the battery to spike to 600 C in seconds, that energy is going to flow along the less conductive electrode material. So you're releasing the same amount of energy, it's just over a slower amount of time, allowing the battery to fail gracefully. Now, just one thing to point out, it's a little different than how a shutdown separator works, which we're all familiar with. The shutdown separator is controlling ionic flow within the battery. We are actually controlling electronic flow within the battery. And so you can have a situation where your shutdown separator melts and is no longer effective. The SafeCore will still work. And the other key point about SafeCore and a differentiator from other technologies, it can be triggered by temperature, voltage, or current, or a combination of those factors. I don't have time to go through this, but this just shows how SafeCore lines up with other safety measures. And the thing to point out is we check all the boxes, internal short, external short, and overcharge versus other things out there. Key benefits, major thing to point out, no capital equipment. So we're using the equipment that the battery manufacturers have now and are coating their electrodes with. And the material is very cheap. We're not selling the material. So the increase in the materials is very minimal. Market opportunity, the takeaway from this is SafeCore is applicable to all of these use cases, and we're working in many of them now, which allows us to avail ourselves of a very, very large market. So our commercialization path and progress, we are a licensing tech transfer model. Right now, we start with the evaluation of SafeCore. We've got over 12 evaluations in progress. And that's with EV companies, wearable companies, laptops, home electronics, batteries, and materials companies. And these are all marquee companies that you would know their names very, very well. We've already signed 2 royalty-bearing licenses, one in consumer electronics and one power tool, which is Stanley Black & Decker. We have another one in the pipeline. We are currently in tech transfer with 2 of the top battery manufacturers that were selected by our licensees. And our planned first product will be in the market Q2 or 3 of 2021. This is our team. We have a very experienced team. Qualcomm was our Series A investor, and so we do have a Qualcomm board member as well as a former president of Qualcomm, my COO as a senior executive at Qualcomm, and then our founder, Dr. Jing Fan, who's had over 30 years experience in the lithium battery market. So our series, we're looking to do a 5 to 10 million raise, and really this is to expedite our tech transfer and scale-up process to get our products in the market, and then also look at our next generation R&D and what SafeCore, the next generation of SafeCore looks like, and some of the other technologies that we have coming out, and then to continue to expand our robust patent portfolio, and then finally, we really have started to work with regulators and government bodies. We see SafeCore as something, years from now that you wouldn't think of building a battery without it. So you wouldn't think of building a battery without a shutdown separator. We think that down the road, you wouldn't think of building the battery without a SafeCore layer in it. And so we really want to spend some time to educate regulators and government bodies on that. And that's it. Thank you.
Thank you, Jenna. Okay, so now is the time when we start the Q&A session. Rokas, Jesse, Friedrich, the floor is yours.
Can I jump in right away? Presentation. Great to see you tackling this problem, which is really needed to address. Just a technical one first. It's clear how you delaminate part of your stack, but the energy needs to go somewhere, right? So I'm a bit confused. Where do you really quench the process in itself, or does the energy that gets there find another way out to be detrimental?
Yeah, no. So that's a great point. So I just pulled up this diagram. I think you can still see my screen, right? So the energy is still being released. So you're exactly right. We still have to release the energy within the cell. However, without the SafeCore layer, that energy is going to release along the highly conductive current collector, the metal current collector. And so once you created that delamination, you're forcing that release of energy along the electrode material, which is much less conductive. And so it just basically releases over a longer period of time. And so you don't have that spike. So if you look at, for example, our nail test, when you do baseline and SafeCore, you'll see in the baseline without SafeCore, when you nail the cell, that temperature spikes immediately to over 600 C in some cases, and basically a temperature above the flash point of the electrolyte, right? And so that's why you see the fire. With the SafeCore cell, you'll see that temperature sticking, 60 C, maybe around there. And that's because it's still being released. It's just being released slower. So you're not having that massive event.
Right. Thanks.
Could you help us with your business model a little bit? Understanding that you fit right into the battery manufacturers' lines, existing equipment, and so forth. So can you explain sort of where you're applied? Is it?
I think you might be on mute.
I'm not, but doesn't seem like the audio is working.
Oh, there we go. I can hear you now.
Okay. Well, let me try again. How's this?
Yes, I can hear you.
Okay. Could you just explain the business model a little bit more? I understand you fit into existing manufacturing lines with existing equipment, but what about the inputs to that? How are you going about the material sourcing and production? Is that something where you develop a line and then sell in, or can you expand on that a little bit?
Yeah, absolutely. So our process has been, we license to the product company, so the consumer electronics company or the car manufacturer, and then they give a have made to their battery manufacturer. And so we're not selling the material. And so essentially what we do in our tech transfer, we do the upfront prototyping and design of the SafeCore cell for their application. So we actually have a battery manufacturing facility here in Carlsbad where we can make up to 1 million cells per year. So it's a small factory that really mirrors what the large volume manufacturers have as far as equipment. And so what we transfer to the volume manufacturer is essentially that recipe. And so we do all the prototyping here, and then we transfer a working cell to the manufacturer. And so we'll actually do, we run current with our SafeCore layer here in Carlsbad, send that to the manufacturers, they build cells. And then as the next step of the tech transfer, we teach them how to build and coat cells with the SafeCore. And then just real quick, our license agreements, so they're royalty bearing. So that's where our revenue is primarily from. Of course, there's some upfronts, and we also, all of our evals are paid. And so we actually are get revenue from those evals, but our significant revenue will come from the royalties once the product's in the market.
Thank you for the presentation. I just want to ask a short question. I think it's mentioned in your website that you can potentially expand the range, for example, in the application of EV battery, just due to lighter pack. Could you extend a bit on that as well?
Yeah, absolutely. So interestingly, the genesis of this technology was partly funded by an ARPA-E Department of Energy grant here in the US. And that project was actually to build a multifunctional cell for the EVs. And so the idea is if you can build a battery that is fundamentally safe at the individual cell level, then what does that enable you to do with the design of the car? And so, for example, we did modeling on, okay, now if you don't have to have such a heavy protective layer of steel around those batteries because they're safer, then, does that enable you to get a further range? Does it enable you to now develop a battery management system with less redundancies in the BMS and take out, some of the cost? Can you now put battery cells in areas of the car that you otherwise wouldn't have previously? And we're also out working on our military side and aviation, looking at some of that. So it really opens, some, down the road ability to change the design of the EV.
Okay, great. Thank you, Jenna and the guys, for the questions. We are moving now further with our second contestant of the top 5 finalists. So next up is Battery Intelligence, straight from Finland. And their head of business, Marcus Manx, is going to represent the company. So Marcus, the floor is yours.
Thank you very much. Hopefully you can hear me. I'm just trying to pull out the presentation here. So let me just have a technical issue here. Just a second.
Running, of course, Marcus. we discounts here. Okay.
Despite these technical issues, I'm representing a company called Bamomas, based in Tampere, Finland. And what we do is that we bring intelligence to industrial battery fleets. We focus on large industrial batteries, which often are very expensive assets. So that's our core. The key problem that we try to solve in the marketplace is that industrial batteries are black boxes, and there's basically no data or traceability available at the moment. Also, non-optimal usage and performance of batteries, and especially bad batteries, cause huge problems. And unfortunately, they don't last forever either. These transitions into operational downtime, productivity, and profit loss. And that's the key problem in the market. Our solution is a battery as a service cloud platform that connects value chain and supports the circular economy. For battery manufacturers, it gives insight to real-life battery performance, unifies overall battery management, and also decreases the battery warranty and liability-related issues. For battery fleet operators, it enhances the cost efficiency, enables full traceability, and predictive battery maintenance. It also boosts productivity and profits, increases service levels, and enhances safety factors, and last, also improves battery second life and second life resale values. For battery users, it increases the uptime, enables predictable monthly costs, correctly sized battery fleets, and finally eliminates battery degradation concerns. The market that we tap into is of 15 billion euro in value, and the key verticals that we tap into is material handling, forklifts, railways, utility, and golf. And the industrial batteries market actually consists of mainly lead acid and nickel cadmium, which represents 90% of the market, whereas lithium ion only represents 10%, but it's still on the uprise and in transition, so to say. Our product is an integrated platform with a web application or user interface through which our customers can get more insight and in-depth information about their batteries in terms of battery charge, health, voltage, current, temperature, water levels, etc. We have also developed an industrial battery sensor, which is a Maxbox-sized small sensor that can be attached to the batteries, and that collects the battery data and then sends it through Wi-Fi to our cloud-based web application, in which then the deeper analytics will take place. Our core competitive advantages are cloud-based analytics, battery lifespan prediction, cheap sensor. We are far cheaper than our competitors. And then we have also a patented non-intrusive sensor reading. Since 2018, we have run several pilot programs, for instance, with Rokla forklifts, handicart golf carts, the Russian railways, and just about to finalize a big pilot together with Fortum, which is one of the biggest energy operators in Europe, and with whom we are just about to sign a commercial agreement with next week. Our business model is based on selling hardware for 35 to 50 euro per sensor, and then a subscription fee, software subscription fee for 3 to 8 euro per battery per month. And we are tapping into a market of 15 billion euro in value, and we envision to have 225,000 batteries connected by 2023, which translates into almost 18 million in top line by 2023. Our executive team consists of Pavel, our CEO, Evgeny, CPO, and me in charge of the commercial operations, and then Jeroen in charge of sales and marketing in Netherlands and Central Europe. We also have, in addition to this, of course, an extensive R&D team and technical team to support the product development. We have year to date raised almost 300K from Rockstart Accelerator Program, angel investors, and also a Finnish venture capital company called Grid VC. And we are currently seeking to raise 1 million with a company valuation of 5 million. That's it. Thank you.
Okay, thank you, Marcus, for your insights. The judges, over to you.
I think Threek is biased here. He's an existing investor. So I'll start off with a question. So with the current application that you have, what's the total addressable market for just that? Meaning, these light electric vehicles or that you're currently tackling and using the operations. And maybe you could expand a bit more with the partnership on Fortum. Is it like, what type of business model? Is it you're charging is it software as a service model with some bit embedded upfront cost for installing your device or any other?
For very good questions. First of all, I would like to emphasize on the fact that we are not tapping into electric vehicle battery monitoring. We are more into industrial battery.
Sorry for that.
Received wrongly. But naturally also within the industrial batteries, there's different type of chemistries, including lead acid, nickel cadmium, and lithium ion, which of course can be seen also heavily now in the EV market segment, but we focus more on industrial batteries, and that's our core. And then in terms of the partnership with Fortum, they also have a subsidiary, Fleetly, and they have actually created a battery intelligence platform as well, and we provide to them both our sensors for battery data collection and then also the connectivity and the battery analytics. So it will be a recurring invoice-based commercial agreement to be signed most likely next week.
Just for one clarification with regards to that, is it a per vehicle charging model or more as a general sort of licensing fee for your analytics platform?
It's a software subscription fee that is based on a recurring monthly charge on a battery per month level, and then in addition to that, we of course sell the hardware, the battery sensors for the batteries to be monitored.
Thank you.
And I would like to highlight here also that Fortum, for those who don't know that, it's one of the biggest energy operators in Northern Europe with some 70 billion euro in revenue. So it's a very, very interesting partnership that we are just about to sign a deal with.
So battery as a service really looks like software as a service. Batteries underpinning that. So it's not like a performance guarantee of, X delivery of the battery power or energy. How does that? Could you expand on the contract a little bit more?
Yeah, so I mean, through our solution, through the hardware and the battery data collection, and then the analytics, the web application, we can actually provide deeper insight into the battery performance, generate also predictive maintenance solutions so that our customers can actually enhance the understanding of the battery performance. And we can also predict the end of life cycles for batteries. So it has a very strong impact also on the whole life cycle of batteries and the sustainability factor.
And how does that differentiate from the BMSs that you already see, or do they just not exist really in these markets that you're seeing?
Well, currently, I mean, the BMS that is out there, we are kind of extending that and getting even more deeper insight into the battery performance and the usage patterns, and based on that, we can then, through our algorithms, generate predictions that is not available at the moment.
Thanks.
Yeah, I've been holding back because we've been involved as an investor in Baumomas from a very early day, but I think it's interesting to share some of your insights that you gained from working with different types of customers and customer applications. What do you see as the typical sweet spot now for immediate benefit for customers based on your experience in different sectors?
Well, out of these, I would say 3 key market verticals, like material handling, especially forklifts and railways.
Isn't this supposed to be a pitch session?
No, I think there's just some sort of a glitch.
And Marcus.
Can you hear me?
Yeah, we can hear you.
Okay, so I was just trying to say I have some connection issues here. So that out of the key verticals that we have, the forklifts and the railways and the utility vehicles. Can you hear me now?
Yeah, I'd say talk through that. I think we're crossed over to the
some other panel or something, but just go on, Marcus.
Yeah. So, I mean, out of the experience and the pilot programs that we have run, we have substantially increased our customers' insight. Basically, as described in the pitch, the batteries currently are just black boxes. There's no information available, at least not on the level that we can provide them with. So, different type of predictive maintenance and usage patterns, conditions of the batteries, real life and online real-time battery information has been of real added value to our customers and the pilot cases that we have executed.
How do you support the product with so many sensors out there? What does that look like in terms of channels for you?
You mean technically speaking, or?
Yeah, exactly. So you know, it's the hardware deployment that I'm really asking about. There's going to be a lot out there, and so how do you, as a team, how do you address that? What do you do for channels?
So we are actually, gentlemen, out of time. So please take this question real quick, Marcus.
Okay, so that's a good one as well. So of course, I mean the hardware is always a little bit more tricky than software in terms of scaling. But the beauty of this solution is that it's not rocket science. I mean, in terms of the hardware, and then the installation can actually be done also remotely. We have very good videos and instructions in place, so that hardware installation can be done very quickly and swiftly remotely without us being necessary on site.
Okay, cool. Thank you so much. Thank you so much, Marcus. Very cool product and good luck with it. So we are now moving on to the third company, which unfortunately couldn't join us here from the live studio with their pitch, but it doesn't mean that they are disqualified, as our judges will be watching their pitch a little bit later after this live session. But this brings us to our fourth contestant already. So our fourth company is Lindsay Energy Storage, and they will be represented by their CEO, Raphael Meyer, straight from France. Raphael, join us. Hello there, and your time starts now.
Okay, can you hear me?
Yes, we can hear you.
Okay, thank you very much. So thank you very much for selecting us. I would like to share with you some ideas on how building a world of prosumers by combining high efficiency devices and as a service energy offers. And I would like to start with this concerning fact that in Europe, for instance, buildings heating represents more CO2 emissions than transportation. And elsewhere, that's the cooling of the building. That can be a majority of electricity consumption. And that means that we have urgently to replace massively those old HVAC systems with a new generation. And we think that we have the proper version for that, which is an MVP dedicated to heat generation, an electric radiator with smart features and a battery storage. It's an exclusive solution, 11 patents families, a Best of Innovation in 2018 CES, and a grant from the European Commission. It's a system that is plug and play, that uses electricity to generate comfortable heat. And then, with the help of some sensors, a smart meter, and self-learning algorithm, we can save energy with an autopilot. We have then this battery storage asset, 800 watt-hour storage, 500 watts of micro-inverter in each single device to re-inject the power of the battery within the domestic grid. Then imagine that you have 1 to 2 devices per room, and that you will aggregate then this capacity at the scale of the house or the building. And that brings you the perfect platform for self-consumption, to valorize a PV production 100% of the year in self-consumption. Last but not least, we offer to our customers 2 options. First, a fresh battery, no installation cost and a long lifetime. But that can be also a second life battery. In this case, it's much cheaper and a reduced footprint. And it's pretty ambitious project is deployed with the Groupe La Poste in France. We have already 10,000 electric bikes deployed in Paris. And those bikes will give their batteries without remanufacturing for a second life in stationary storage use. And as a result, we can offer the cheapest storage solution available on the market today if we talk about the cost of operating kilowatt hour. And then imagining the bundle that we can build around, you're going to have the shortest return on investment for a storage system. Then keep in mind that we have some additional revenues that we can generate. For instance, with the fast containment reserve or the demand response. It's upstream of the matter, and it's a recurring revenues that we can monetize. With those facts, we can explain our go-to-market strategy. First, in B2B, it's our historical channel. 1,000 units to date with social landlords, for instance. We sell directly our bundles to them, and we propose them an option, which is an as-a-service offer. With third-party investor, we will pay for the upstream investment, and of course, propose this system as a service in order to valorize all the recurring revenues that we can generate. Then B2B2C, it's to come by next year. First, with energy supplier, we have ENGIE as investor, and we are discussing with them about selling them the product, and they will build them their own bundles for their own customers. Last strategy is to license the technology to manufacturer. We've signed already with the Canadian leader to cover the North American market, and they will produce their own systems powered by Lindsay, and then selling them to their own customers with their own channels. Of course, we will build the infrastructure to make the management of these batteries and make some recurring revenues out of the management of them. Ambitious roadmap, ambitious team, 35 people based in Grenoble, France, and different partners around us. We started this adventure in 2016. Last year, we made a Series A fundraising to launch our first operations in self-consumption. It's an objective that we have fulfilled recently with EDF despite the coronavirus. Next year, B2B2C and first licensing. 2022, the first as-a-service offer and second life battery introduction. 2023, generalization of this process worldwide. With those roadmap, we want to reach profitability by 2022 and the very ambitious number of 100,000 prosumers by 2025. And we are organizing right now a Series B to cover this strategy. I hope that I've convinced you that the energy future can be desirable. For us, definitely, it's going to be an electric future. Thank you very much.
Excellent. Thank you so much, Raphael, and good luck with the Series B. So the judges, floor is yours.
If you can hear me, I'll jump in here. I was curious about the revenue splitting model. Can you walk us through that a little bit on the B2B2C?
If I go back to my slide, or maybe I cannot. Okay, apparently it's blocked, no problem. So basically with suppliers, it's pretty simple. Actually, we sell to them our systems with the app, with the APIs, with all they need in order for them to propose to their energy subscribers a complete bundle where you're going to have the energy supply provided, for instance, by Engie. You're going to have our systems, maybe other systems, and of course, the installation. So for us, it's selling one shot our systems to the energy supplier, and they do the rest of the job, which is for us, of course, very difficult to touch the end user directly. And we don't want to be involved into this process. So we let the energy suppliers leverage, in a way, all the benefits that can be done for an energy subscriber that way. Engie will also collect the recurring revenues from the grid services. It's pretty normal as they invest into our solutions for their end users. And of course, they will use our management platform. So in a way, we are the infrastructure manager of those batteries. We are not the demand response responsible. We are just creating the pathways between the demand response orders and the hardware itself. Last but not least, the idea, as you understood, is to, as much as possible, propose those systems that are not that costly, but that can be, for some people, still pretty costly, to propose those systems, or to generalize the fact that those systems can be proposed as a service. I mean, without initial investment for the end user. And energy subscribers will use those options that are a kind of second product on top of the hardware solution itself. And then you can choose. Either you invest into the systems, and it's like the Zonon model, if you will. You get all the benefits for you. The electricity supply, the electricity production from your rooftop is for free. And potentially you enter the Lindsay community or the Engie community in order to collect the recurring revenues from the grid services. But what we think more ambitious is indeed to create or co-create those as-a-service offers without initial investment. The energy supply will be still lower than the national electricity grid. And of course, you're going to have all the maintenance, all the services around to leverage the best these solutions. That's for the energy supplier. And then for the licensing of the technology, it's pretty classical. For instance, with Stelpro Design in Canada to cover the North American market, they have access to the patents. We co-developed the hardware solution that will be then produced under their production lines and distributed over their own channels. And we have a royalty at the beginning and a fee for the recurring fee for the accessing the management platform for the battery management system.
Can I ask a question here before you run another pitch? Is this application also suitable in markets where gas heating is dominant? I'd imagine,
like Holland, for instance.
Like the Netherlands, yes, and different from France, for instance. Can you comment on that?
Absolutely. Yeah, sure. Well, first, thanks for this boulevard, Frank. Indeed, as you know, in the Netherlands, for instance, since 2018, the connection to the gas network is forbidden for a new building. So let's consider that anyway, sooner or later, the gas boiler will disappear, at least under the shape we know today. Maybe we're going to have some hybrid systems later, but so for sure, what we postulate, and that's one of the postulates of the Sky scenario of the Shell company, is that anyway, the electrification of the heating is a massive process in Germany, in the Netherlands, in the UK. It's going to be the same. So for sure, we will not be able. Our solution will be not the best for any cases of replacement of a gas boiler. But in some cases where it's going to be complex to replace, for instance, the fluid network with the old fluid system, where you have some issues with the regulation, etc., we're going to have a very, very simple option to propose for a massive retrofit of an old building equipped with a gas boiler. Then, last but not least, by 2024, we plan to have a heat pump, an electric heat pump with a battery storage and the same, if you will, approach than we have right now for our current solutions. But it's not ready yet. But already, the market is huge for this pretty simple shape of electric heating system.
Okay, thank you, Raphael. And this leads you to your timeout. So we are moving forward. So the least but definitely not the last company pitching today is Soteria Battery Innovation Group, straight from the USA as well. And their CEO, Brian Morin, has joined us live. Brian, do you hear us?
Yep. Yeah, I can hear you guys fine.
What time is it on your end?
6:40 in the morning.
Wow, nice. Early bird. Okay, so the stage is yours. You have 5 minutes.
Great, thank you. My name is Brian Morin. I'm the CEO and co-founder of Soteria Battery Innovation Group. We are a company that has formed a group of companies. Let me go. There we go. That is dedicated to lithium-ion battery safety. Two things you need to know about us. One is we have a technology that can eliminate fires and make batteries much more safe. And two, we have formed a consortium now over 70 companies to take this to market. The consortium has 4 purposes. The first is that we put our technology out as an open innovation platform so that each of these companies can advance and protect their own business using our technology. Think of it as the Microsoft IBM business model, where we have the operating system, and these guys are making the printers and disk drives and everything else to make it work. We're taking it to market by doing 3 things similar to the Bluetooth business model. The first is to set up a supply chain that's acceptable to the automotive, battery, and electronics industries by licensing the technology to advanced materials companies. And then, because our batteries will pass safety tests that every cell made today will fail, we're going to set an uncompromising safety standard. And then for the batteries that can be certified to that standard, they'll be able to use the Soteria mark. Soteria is the Greek word for safety. It's the only thing it's ever going to mean in the market. The best way to tell you what we're doing is to show you. And what you're about to see on the video. Hold on. Yeah, okay. So here goes. Sorry. This is a 3-cell pack made with lithium-ion batteries. The control cell under this circumstance will burst into flames. Ours not only does not burst into flames, but it continues to function. You'll see the cell here attached to a drone. This drone is a 15 amp draw on a 5 amp hour cell, so it's a very high power application. Would drain the cell in 15 minutes. And guys, this is the only lithium-ion battery on the planet that will actually do this, which is continue to function after it's been damaged. Our value proposition has 3 pillars. The first is the revolutionary safety that you just experienced. The second is what we call no compromises, which is that this technology, because we do it by taking out metal, gives us a 20 to 30% weight reduction and lower material costs because the copper we don't use is expensive. It's a drop into every lithium-ion battery manufacturing plant. This is a normal lithium-ion liquid electrolyte battery. And then the other thing is we deliver the same electrical performance that you get in the batteries that don't use our materials. Our technology is embodied in two materials, a current collector that's made from a metallized film instead of a metal foil, and a nanofiber-based non-woven separator. These are manufactured today by the companies that you see in the middle of the page at the scale of about a half ton an hour. So this is scaled to manufacturing today, and we've proven that it's a drop-in with existing coating, stacking, and winding in lithium-ion batteries. We're starting our entrance to market by identifying critical environments such as first responder handsets, electric vehicles in mines, military applications, and drones, where our product is not a vitamin, it's not aspirin, it's a defibrillator. They have to have it. We'll be launching in those markets in 2021 and transitioning to the adjacent mass markets in 2022 and beyond. If you look at our supply or our consortium spread out among the supply chain, you see that we're very well represented. Our business model has three sources of revenue. The first is membership fees. We got $200,000 in 2018, $480,000 in 2019, and we'll be over $600,000 this year. The rest of the return comes from the long-term royalties, which is the gray stripe in the projections you see in front of us. The beauty of our business model is that our potential exit partners are already engaged with the consortium, already doing their due diligence, advancing and protecting their own business and technology using our technology. Obvious social and environmental impact with the safety and the promotion of electric energy, but also help in the mining. We have a very experienced management team, and I gotta go quickly. A also very experienced board of advisors. We've won several awards, and we are completing a $2.25 million Series A now. So with that, I'll stop and take questions.
Thanks, Brian. Thanks for a great presentation. Just a quick question. So in terms of the supply chain, so as I understand, you're sort of creating a new architecture for the lithium-ion battery in a sense, to some extent. How are you fitting in within that supply chain? Like if I'm a Cathal or I'm a Panasonic, what has to change with that respect for them to be integrating you?
Yeah, so the only thing that has to change is they need to purchase the current collector and the separator from different suppliers. It'll drop into their manufacturing and the batteries will look and feel the same to their customers. And that's the reason we stuck larger suppliers into the supply chain rather than trying to be the supplier of those components ourselves. They'd much rather buy from a DuPont than buy from Soteria.
And sort of what next steps you seems like you're very connected in terms of the industry and this consortium that you just presented us. What sort of next step is required for you?
Next step. The thing we're doing now is we are producing thousands of batteries with select partners and then distributing these batteries to the end users who are building devices. So we've got 18650 cells as well as the pouch cells that you saw. And they're being built into everything from drones to Motorola handsets. The idea is that by the end of next year, we will have between 30 and 50 of these small devices made. Think everything smaller than a golf cart.
Okay.
With immediate commercial intent with about a half dozen to a dozen of those by the end of next year.
Cool. Thank you.
Can I ask the next question? What is currently the most limiting factor for you to reach scale, to make the next leap? So what will be pivotal for your next funding round in that sense?
Yeah, so the big thing, and we've just overcome it, is we were delayed by somewhere between 3 and 6 months in getting cells out of Asia to be built into devices. So we were expecting them at the very beginning of this year, and we've started getting them now. And so now the trick is to get enough cells and get them into the hands of the end users. The big milestone for the next round will be, do we get those 30 to 50 devices made? How many of them work, and how many of those customers want to take them commercial?
How do you see margin protection under the supplier, the contract business model?
Yeah, so I mean, the beauty of the business model is that it's very capital light. Obviously, we don't have to have a big team. We don't have to have any assets in place. And then what we're doing is we're charging a 5% royalty at the component manufacturer. They get a cost down, so they're going to be able to deliver the product at a lower cost than their competitors in the market. And the trick for us is to have, my thought is, between 3 and 6 manufacturers of each material, each delivering globally, and that number of relationships, so 6 to 12 relationships with licensees, is a manageable number of relationships. And so, but we get, our take on the end use battery is only between 0.5% and 1%. So we need broad adoption to make lots of money. Of course, even a few adoptions will support the company, but to give a big return, we're going to need to get broad adoption.
Additional question, if there's room, with regards to the supply chain, would there be risks involved in a world where supply chains get disrupted? How would that affect you, or would you be able to deal with that?
So kind of two answers. One is we think we're setting up a supply chain that's rational for the industry. The other is that as we grow as a consortium, we think we become the natural place for a Stanford or an MIT or a Fraunhofer to take their next battery technology to market with by having us do the scale up and development and then license it through our consortium to the industry. Especially for safety technology, the industry wants broad adoption. It helps everybody if the battery industry gets safer.
Okay. Thank you so much. Thank you, Brian. Thank you, the judges. So I think we are now fully equipped to cast our votes. So the winning battery company will be announced on this Friday at the closing of the Energy Tech Summit. But we are moving further. Oh, no, one quick mention that I wanted to say. We have some poll information coming in. So there are a couple of winners already from the audience side. So I'm just going to quickly go through them. So the audience's favorites are ammoniacs, G batteries, and Soteria. So, well, I'll give you that already. Anyways, so I wish all the contestants best of the luck in this competition, as well as with their products and companies in future, of course. And this also brings us to the last panel of the battery segment today. So basically, Jesse and Freerk, our judges from the pitch competition, not so fast because you guys are joining us in the studio once again. And then we are also having James Adams, who is the partner at Alexa Capital, and also Bala Nagaryan, who is the investment director at Equinor Energy Ventures. So our participants and dear key industry leaders will discuss whether batteries have the potential to replace the grid, and will share their perspective of the future of energy storage and batteries. But we have some time now. Can we get Rokas in the studio? Yes, we can get Rokas in the studio, but it's going to take a bit more time. So basically, I wanted to go through a couple of questions with Rokas regarding the pitch competition and how was the process going on before we got to the finalists. Seems that we are having some technical glitches. Okay, can we get Rokas in the studio or not really?
Yeah, I think yes. Hi everyone. So I think today marks one of the first of the 6 competitions to reach the final per each of the sections that we have as part of Energy Tech Summit and New Energy Challengers. So on Friday, I think we're going to have 6 winners released. And what we kind of pushed and we introduced yesterday through our Ask Me Anything panel, I want to clarify and a bit more context to it. So on Friday, we're also going to release some news about the Investor Top 50 event that we're going to have later this year in December. And the great part for the companies is that it's going to be even more investors in one place. And the idea is going to be to more reflect on who are these players in the industry, as well as also the possibility for these top 6 teams from all of the subcategories to be able to pitch in front of them. And we expect to have over 40 investors from all across the world. So this is going to be a great opportunity as well for the finalists of New Energy Challenger before we actually release the number 1 and the only winner of the contest. So this is going to be a bit at last think of 2020. Hopefully no more surprises such as COVID or something that can intervene in this process, but therefore I'm very hopeful that it might even happen in person, but if not, then we're going to do a virtual session as well. So I think this is being great, and it's been great so far in the Energy Tech Summit. I'm sure that's going to be the same for the Energy Tech Investors event that we're planning later down the year. And thanks again for having me for the battery pitches, and I think we're going to have a great next panel discussion between Jesse, Freak, and also Jameson from and Bala, who haven't seen for a while live, though. It's unfortunate they cannot join us in person here in Vilnius, but looking forward to hear from them.
Yeah. Mm-hmm. So I was quite impressed with the stage of the companies that have you guys gathered for this competition. So I believe those investors in the follow-up investor session will definitely have some leverage over that. So I hope a lot of them will join in.
Absolutely, and I think what's actually interesting in general, what we saw from New Energy Challengers competition, there's been over 200 contestants, which we kind of shortlisted of top 10, and now we got to the final 5 per category. And I think this shows really the maturity of the sector, and I think this has been really, really great. To see so many contestants that are, already are in a later stage of the product development and are actually seeking to find financing, right? And I think we primarily, as Contrarian Ventures, really sought to see these kind of hurdles from even our own portfolio. Having to raise money even became harder through COVID. So I think these virtual events like Energy Tech Summit, and we're trying to bring people in these competitions to be able to access capital easier, as well as to get feedback, find partnerships, sell to new clients. And I really, as I said on the day one at the opening, I urge everyone to kind of engage in this dialogue. And I think we have this great virtual platform that you can schedule meetings, meet people. Don't hesitate to do that. I think this is a great option. You have still today and the next 3 days to do that. And really what we're saying, we're going to launch this as a more bigger network, which is going to have functionality, not just the side of typical fundraising and meeting investors, but this is also going to have a flexibility for you to even engage in an HR function, so you can be able to hire people, which I think of the hurdles of the teams that are building great products. HR is one of the hardest things to do, and to really build a great team around this and pursue the solutions that they're developing. So I'm really thinking that, we definitely need, and we engage partners that we are currently working with, funds that we're currently working and co-investing to really be the first, pioneers to use this, as well as our, in a way, evangelists, and engage everyone from their portfolio as well as from their other co-investors to join us. So this is just the first sort of a showcase that, virtual can happen and can happen very successfully. And I think this is what we're trying to aim to do here.
Great. Can you guys hear me? Yes, you can. Okay, thank you so much, Rokas, for joining the discussion with me for a quick one. Anyways, we are now ready to move forward with our panel. So as mentioned, we'll be joined by James Adams, partner at Alexa Capital, Jesse Teichman, investment manager at Chevron Technology Ventures, as well as Bala Nagarian, the investment director at Inquire Energy Ventures, and least but not last, Friedrich Bishop, who is the director energy at Rockstart. So, folks, please join us on the stage.
Good morning all, afternoon for some of you.
Good to see you.
Good morning.
Welcome, welcome. So, very good. Storage and what are the impacts batteries are having on our grid, I think is the topic here. And of course, the question of where are the opportunities in the current environment. Do we want to do a quick introduction or put it this way, when you speak, perhaps you could just give a sort of brief introduction as to who you are and your role and your interests. I guess we just get straight into this and perhaps think about and ask ourselves the question, or the first half of the question: what do we think is going on in terms of batteries, and how is that affecting the grid, and how is that maybe affecting the distribution grid over the transmission grid? Is it just about increasing or reducing the need to build more transmission network as a result of having these buffers on the system? Is it a question of looking at storage sitting sort of deeply embedded in the grid, and indeed even at the point of consumptions in either at commercial and industrial sites and or residential sites, so as to alleviate the burdens on the grid, particularly as we move to electrify heat and transport. So be great to get perspectives from each of you, perhaps on the first part of that question, and then we can talk, spend a bit of time talking about the investment of opportunities and how you see that evolving, because there are some big numbers out there and big growth expectations. So it'd be great to get a perspective on where we think those are going to happen.
All right. Anyone objecting to me starting?
Go ahead.
All right. It's great to talk about batteries because they continue to surprise us. So it's a difficult task at hand for us to look into that future in that crystal ball and give some clarity. But at Rockstart, we've been investing in smart energy startups for a couple of years, and we are about to add more funding capacity to be able to extend our support from pre-seed into Series A and B funding rounds. I'm excited to be in this space this day and age because the battery technologies have developed into such a safe, reliable, and affordable way that they can be deployed in many ways. And I see it as a natural extension of the grids, because the grids have their omnipresence, but one issue that they only can serve on a real-time basis. And what batteries add to that is to create short or longer term time management on top of that, which I think is the principal benefit of adding batteries. And there you see a lot of cases happening, which I think in general strengthen cases in local grids. So it makes the local grid, the distributed grid stronger, whether that be at the customer or in environments where several customers are connected to a grid situation, and more resilience is built in as soon as batteries come in, whether or not on wheels. That's for later in this discussion, I would think.
I can go next. Everybody knows Jesse, so maybe time for me to introduce myself. I'm Bala Nagarajan. I work at Equinor's Clean Energy Growth Equity Focused Fund. We've been investors in battery storage both on the technology side and on the business model side. We have invested in front of the meter and behind the meter battery storage developers, and also looked at residential battery storage aggregators, and have a host of investments in up and coming battery storage technologies, including one called Natron with Chevron as co-investor as well. I think when we started on this journey looking at investments in the battery storage space, we were thinking of battery storage from a market perspective, both from a geography perspective and from a use case perspective. For instance, where I'm going with that is we saw, for instance, much higher adoption of battery storage, particularly on the utility scale side in North America compared to Europe, because utilities were coming up with RFPs to procure front-of-the-meter battery storage, particularly in California and Hawaii. And we saw that market growing much faster than, for instance, residential storage batteries. But clearly, over the years, since sort of 2014, 2015, we've seen that we're finally at a point in time where the battery storage applications for behind-the-meter residential use cases is now certainly sort of inflected, and the pure number of megawatts installed of residential storage is now at a meaningful level, which further encourages the economic case. And from a market perspective, the UK market, for instance, which is an island market, and therefore has a much higher share of intermittent generation in the energy mix, is one where you would expect to see a lot more installation of storage. Policy has been a big driver of that, but policy has also been a reason why people have not invested as much as they should have in battery storage in the UK. So in summary, I would say the way we see these markets evolving is a function of geography, it's a function of policy and of specific use cases, and we can go into all of that in more detail further down the discussion.
Yeah, a lot of good points, Bala. And I want to echo some of those, but first of all, yeah, again, it's Jesse Teachman. I'm an investment manager with Chevron Technology Ventures here in Houston. You may hear a lot of rain in the background. We've got a tropical storm blowing by at the moment, so it's been an interesting day or two. But in general, kind of a similar thesis. We typically target Series A and B earlier stage as a non-lead investor in spaces related to the energy transition and especially decarbonization. And so in three main pillars, we look at macro decarbonization, the mobility energy nexus, and energy decentralization. And so, of course, we see a lot of crossover between the mobility space and the distributed energy space. And I think that with the opening theme of the discussion today is, will batteries replace the grid? And I think as you look at the mobility sector, perhaps that's the one sort of wild card here that might upend that thinking, right? If you try to imagine sort of this counterfactual of the EV charging network on the growth rate that we expect, kind of absent an electrical grid, it's obviously sort of an extreme proposition, but it is a little bit hard to imagine. So, as Ball alluded to, I think there's a lot that's going on the policy front. It's, perhaps in the United States, starting with FERC Order 841, which is allowing batteries both behind the meter and front of the meter to participate in these markets in a much more meaningful way. I think that's opening up, perhaps will open up substantial growth there. On the UK side, I think with this loss of inertia, as you have more and more, conventional turbines, driven by coal or gas, for example, coming off the grid, I think we're starting to see signs of inertial loss, which is, just sort of this physical mechanism that's there to help balance the grid and just basically absorb shocks from intermittent gains or losses of renewables. And so I think, this is a fast acting response, so you need fairly rapidly acting batteries. So I think that this is an emerging market space, or let's say an emerging theme of interest, as it certainly is. We're starting to see the green shoots of that in the UK and more broadly through Europe. I think in the United States, we perhaps start to see pockets of this in the coming years, perhaps in the states with highest renewables initially, and then as more and more renewables come in, you see more of that. So I'll kind of stop there and
very very interesting sort of opening remarks and perspectives. I just want to pick up on something back to you on something that you were sort of saying. I mean, in terms of replacing the grid, it seems to me that microgrids are pretty good ideas, and so that the consumption and generation can be sort of shared amongst multiple users, and to the extent that there is more consumption connected to the same generation and storage and system, it sort of suggests that then you would be able to sort of optimize energy systems far better by at least enabling the consumption and use to be shared amongst sort of communities. So it seems to me that the complete eradication of the grid is something that's relatively unlikely. Would the panel share that view, or do you see a world in which we have discrete systems that are completely disconnected from the grid?
I would share that view. I mean, first of all, your phraseology of eradication of the grid is just fantastic. I can see almost a sci-fi movie on eradication of the grid. But I would say, yeah, very much share that view. I think that the models where the grid has a role, the utilities have a role with the players, is perhaps the most helpful model if what you're looking to do is decarbonize while maintaining reliability. You touched upon communities, and I think that this is essentially codified now by European law as of 2017, where you have energy communities as a tool in the European Union's decarbonization toolkit, and now it's up to the member states to start promulgating the rules around energy communities. And so that's an interesting theme for us from an investment standpoint, is that we're starting to look at the data, the digital overlay on not just the batteries, let's say behind the meter, but also all the equipment which might go into a community and how to optimize that. And we're even starting to see models emerging where everything, including the transaction, is essentially self-contained within the community. And so I think you sort of have this visual of peer-to-peer, but I think it's sort of like peer-to-community, where you have assets essentially socialized out across a fairly broad base of, let's say, residential, commercial, perhaps industrial users within a given constrained environment. And so you can essentially both from let's say, an emissions, carbon, and also economic perspective, optimize across that community and actually settle those transactions. And the grid plays a role there, because it becomes merely one input to that optimization feature, but a necessary input on the reliability side. And so I think it's an opportunity for the utilities to maintain the clear critical services provide while still making money in this environment.
Yeah, no,
I think it makes sense to try and make a comparison with data. We've seen a shift from cabled data transfer to wireless cable transfer, but we didn't see the cables disappear, right? So I think there's a shifting role for the cables and the grids to take care of a specific portion of the full array of exchanges, which will be massive in impact, and the batteries will definitely, and the storage mechanisms will definitely open that avenue for a complete turnaround of the usage, the deployment of those grids, and the layout and the stacking of those grids at certain levels.
Yeah, and it's certainly a function of the market as well. As an example, a reason why we use batteries is because the grid itself is not clean. Therefore, we want to generate our own electricity, which is for instance, from solar, and therefore use that when we need it. The second is the grid is not resilient. So if utilities and grid operators invest money in making the grid cleaner and more resilient, the case for storage effectively goes away. In fact, the societal cost of each and every one of us having our own battery storage behind the meter is far higher than leaving it to the grid operators and the ISOs and the utilities to manage the grid effect for society at large. And the most obvious case is Norway. Norway, the grid is clean, it's resilient. There's no reason for anyone to have a battery storage behind the meter. And whereas you see a lot more adoption of that for instance, in Hawaii and California, because the grid is not clean enough or it's not resilient.
But you're forgetting one thing, it seems, if I may, because you're talking about stationary storage solutions, but the big portions of the batteries that are coming in the market and have another function of transporting people and stuff can actually play a big role in grid services, grid support, etc. And that does affect the whole play.
Indeed.
Agreed.
Sure.
I think you're alluding to the vehicle to grid model, right? And so that's going to be interesting. I think that sort of the 1.0 interpretation of that is that you'll just have these car batteries out there scattered widely, and you can just sort of pick up on that capacity. I think the reality, though, is that like what we see, for example, in Southern California with the SoCal Edison territory is that, when you do targeted energy storage, in a small amount, maybe 10 megawatts here, 5 here, but sort of with very deliberate geographical locationing, that those small amounts of storage can have a really outsized effect with respect to hotspots. So they punch above their weight class. And so, the locational aspect is extremely important. So the question remains in my mind with vehicle to grid, are you able to get the critical mass of the car batteries kind of where you need them with respect to hotspots, and can they have the true value that they should with respect to hotspot alleviation in the distribution grid?
Yeah, I mean, I think there's probably a world for both systems for sure, and also just picking up on the Norwegian model. I think that Norway have they are endowed with a lot of hydropower, which is a dispatchable clean technology, which enables them to, with inertia embedded in it, the moving parts. So it has a system that can operate in a way that it is not similar to what we see in markets where it's more intermittent wind and solar, which needs to be managed into the grid. So I think I think batteries clearly have a role to play there for sure. So, but I was just looking at the time, conscious of the time. We're sort of 18 minutes in here. Do we want to move on to perhaps your thoughts around what you're seeing in terms of investable opportunities? Thinking about dispatchable renewables and having to integrate renewables. Is there a PV and S opportunity, PV and storage opportunity, dispatchable solar opportunity out there? Is that going to be a growth driver? Or, I think that you've alluded to sort of PV and storage at the residential level as well. Is that where we're going to see sort of the deployment of large volumes of storage in a more sort of secular growth market rather than the perhaps more niche market that we've been experiencing over recent times? Just be interesting to get some views from the panel in terms of where they believe the opportunities arise, perhaps sort of near term, medium term, and sort of further out to the extent that that your crystal balls are are clear.
Yeah, thanks for that question. I would argue that currently we're looking at the first specific niche deployments of storage. We invested in companies that were providing music festivals with battery storage power rather than diesel engines, which seems like a super niche specific market, which is true. Although you'd be surprised how many of those festivals are around. But actually, due to Corona and the limitations of having festivals, they made a huge shift immediately to providing building sites with additional power in a clean and sound-free way. They started to work with grid operators to help them support weak spots in the grids or temporary works on the grid, just by providing containerized battery packs that could be put on wheels and could be put for somewhere for a day, for a week, or a month. So I believe the fact that this battery technology, the storage technologies are just coming down this cost curve, we'll see unanticipated usages by the sheer volume of stuff coming into play. And it is important to, at least that's how we look at it, to keep scouting for smart, small solutions right now and try to investigate whether there is opportunity for them to launch and scale.
Got it. Yeah.
From a purely from a decarbonization perspective, as was alluded to in the earlier conversation, the impact of batteries can be felt much more near term in terms of applications where you're replacing diesel with a mix of solar and storage. And there are plenty of countries around the world where diesel plays a pretty big role in the energy markets. And the economic case, as Freak alluded to, given the battery costs are dropping, adding solar and storage and replacing diesel becomes relatively viable even in diesel prices today, particularly with large corporates and industrial customers wanting to be clean and green. Corporate sustainability also plays a significantly sort of outsized role in pushing them towards decarbonizing their energy consumption. So that is an area where we see a lot of near-term sort of potential to deploy capital at scale. In terms of, because these are all capital intensive sort of plays, and there is a sort of space for us as sort of large energy companies to be deploying capital into those projects. On the sort of more venture technology like space, I'm a big fan of all things around recycling batteries and making second life batteries work harder and for longer. So we're actively looking for opportunities in that space, and I think the ability for, and this also ties back into the whole sort of sustainability angle and circular economy and making sure we use our resources rather than sort of lead them into landfills. So that is a space that will become even more prevalent once we have large scale adoption of electric vehicles.
I think there's two emerging themes here, especially if you're more patient capital. I think if you look at the build out of EV infrastructure, I think that's going to be a really interesting challenge for the distribution grid. And I think it'll be somewhat of a challenge for the operators of the EV stations as well. And so what they're trying to do is create this techno-economic balance. On the economic side, it's a few things. It's the front end cost of perhaps substation or distribution grid level upgrades, feeding into the cost of the EV infrastructure. And then it's different, let's say, price and tariff regimes for the electrons going into the EVs. Specifically, you have time of use pricing perhaps that'll play into that. And then you also have, in many jurisdictions, you have demand charges. And so I think there's an imperative to basically provide a buffer, a techno-economic buffer, such as a high power battery that would sit in between the EV charging point and the distribution grid to allow you to optimize your charging sessions for your customers so that you can make sure that you're in the right tariff regime or the right demand charge regime. In other words, keeping your monthly peaks as low as possible to avoid outsized, let's say, cost surprises from the utility, while also, as you get more and more concurrent charging sessions onto the grid, avoiding essentially starting to drop the voltage and frequency on the grid, for all the surrounding. And so I think batteries will start to see a really key role there, and I think it's also an interesting investment theme.
And just touching on the technology a little bit in terms of the battery technology. I mean, we can see that the automotive industry is driving some very significant cost reductions on the lithium-ion side. In terms of longer duration batteries, is there a place for that? I think that's kind of there clearly is, but obviously at the right sort of price point. The commercials have got to stack up. But do you see vanadium? Do you see alternative technologies playing in here? What's your view in and around that?
Yeah, vanadium certainly is one which resonates with a lot of rational investors in many ways, particularly because some of the new players have come out with this leasing option for vanadium, because vanadium doesn't lose much of its properties over a course of 20 years. So if you're able to reduce the upfront capital capex for a customer and offer a leasing solution, that sort of enables customers to adopt long duration storage much faster than otherwise. But the emerging discussion around long duration storage is now also firmly sort of closed in on hydrogen. So if you're thinking of long duration storage, you should be thinking of hydrogen as much as the other chemistries. So when we think about evaluating these long duration storage options, we always think about, can this be replaced with hydrogen, or is this, and hydrogen is purely from a sort of infrastructure and an ecosystem perspective, very close to us as an oil and gas company. So there is clearly a bias in how I'm portraying this, but certainly one that we need to watch out for.
Yeah,
I agree with Paula. There's sort of a SWOT analysis that would include hydrogen. But also, I think a key question on long duration is how long and when does it go to market? In other words, when is there the market need? I think over the last decade, you've seen this growth predominantly kind of in this, let's say, 2 to 4 hour mechanism, and then there's this perception that you need to go into like an 8 to 12 hour mechanism. But I suspect my colleagues on the panel would agree that we don't see too much drive in the market right now for anything that's nearly that long. I mean, we might see some 6 hour type needs, but in general, we're sort of seeing this sort of sweet spot kind of in this 4 to 10 hour range, perhaps in the future, but going way beyond that, there's just not tremendous amount of evidence there. I would say also that there's been some interesting studies, and these are perhaps data points, not necessarily trends. But a few years ago, I think it was Brookings that went over to Germany to talk to the grid operators and sort of ground truth the needs on high intermittency from increased renewables penetration and what that means in terms of long duration storage. And I feel like the grid operators felt that just through the normal course of grid upkeep and normal expansion, that they could accommodate a really high renewables influx. And I think the number is sort of approaching like 80% before you start to get into the need for really, really long duration energy storage. And so whether that bears out is an open question, but it's perhaps something that I keep in mind as I think about the market opportunity in super long-term storage.
Yeah, interesting.
I would support that notion, I guess, from two angles. One is indeed that there's not a very loud or expensive need for longer duration. So the market uptake and the ways, well, the opportunities to make money are limited. And the other is from a cost perspective. I think there are chemistries that you could think of easily that might do the trick on paper, but then getting beyond the fast-moving manufacturing industry that's built cheap storage in lithium ion, which might not be the optimal technical solution if you would start from zero, but it has its scale, right? So I think there's opportunity for other chemistries on paper, but how and whether at all they can find a path to market where they reach the scale that to become also competitive from a cost level, it's yet difficult to identify, for me at least.
Very good. Well, we're into our last 10 seconds. Maybe that's that kind of ties into to what Bar was saying around second life batteries and recycling, and it might get pretty cheap pretty quick to put a series of lithium ion batteries in place that give you that kind of more duration there, longer power, providing power for longer periods. But anyway, I think that's it. We're sort of out of time here. Thank you all for taking the time and really helpful perspectives. And yeah, look, let's see how it all pans out. But it's certainly an extremely interesting space. And good luck with all the investing. And look forward to hearing how you get on going forward.
Excellent.
Thanks very much. Good being here.
Thanks for the conversation.
All right. So thank you, gentlemen, for joining the discussion, and thank you for sharing the expertise and insights. We really appreciate it. Furthermore, did you know that today it turns out to be the National Batteries Day? So with that, obviously, I congratulate you all on this beautiful day. So afterwards, raise a glass and let's see where this takes us further on. And with this, I want to conclude the Battery Summit for today's agenda. And now we are moving into a bit longer break than usually. So we're going to have 30 minutes to do whatever you guys want. But of course, as always, I encourage you to network, to go visit the booths, or just, have lunch and have some coffee. But be right back in 30 minutes from now for our second part of the agenda, where we are going to focus on digitalization. Thank you, and I'll see you soon.